Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Sunil Kumar Bandar. Students, this is the Transformers through topic wise MCQ series session 3. If you want previous, you can watch in this YouTube channel. Okay, let us start the session. Some of the basic questions we have completed. Yes, up to this one we have completed. If AC supply is replaced by DC, primary winding is going to be 1. The first question in this session, all of you ready? Waiting for the video? You have to share to your friends and please support me. Okay, which of the following transformers is smallest? Students, whenever they have given same KVA rating, the KVA rating is same for same KVA rating. The transformer which having high frequency will be small in size. Area will be less, that is size is less. That is compact in size, small in size. That means if we have the frequency is higher, then we can design with less area. Okay, whenever you increase the frequency, suddenly a big transformer may not will becomes a small transformer, like in movies. In old movies, whenever they give one mantra, what is that mantra? Give in the comment section. Okay, so due to that mantra, the big particle will be going to be a small particle, or man will becomes monkey, like that. But here not happen like that. Whenever we have frequency is higher, we can design that one with less area. Why? Because we know EMF equation is equal to 4.44 pi max Fn. Correct? We know flux is equal to product of area into flux density. So EMF is proportional to flux means A, B, and frequency into N. Okay, so let us take N as a constant. N as a constant, and flux density also make it as a constant. Then EMF is proportional to A into F. So we know very well this KVA is proportional to the EMF. Now KVA is equal to product of EMF and current. So here whenever you are going to operate with high frequency, then if you use less area also, then you will get the same EMF. Correct? So whenever the KVA is same, if you having more frequency, then area will be less. So higher the frequency having, lesser the area. Which is having high frequency is 600 Hz. So it will be lesser cross section area. So less specific weight, so smallest. Coming to the next question. When a 400 Hz transformer is operated at 50 Hz, then its KVA is dash. That means here frequency is reduced. Just now we have discussed EMF is equal to 4.44 pi Fn. How it will be depends KVA. KVA proportional to voltage, that proportional to EMF, that proportional to frequency. If frequency 400 to 50 Hz, that means it will becomes, it will decrease by 8 times. So whenever the frequency decreases 8 times, EMF also reduced to 8 times. Okay, so that means whenever 400 Hz transformer will, is operated at 50 Hz, then its KVA rating also decreases by 1 by 8 times. So the answer is nothing but 1 by 8 times. It is decreases to 1 by 8 times. Okay, if you want, you can check with KVA proportional to EMF means KVA 2 by KVA 1, that is equal to F2 by F1. This is conventional way, no need to this one. Okay, so kVA2 is equal to kVA1 into frequency 2 is 50, frequency 1 400. That is 1 by 8 times. Answer is option D. Coming to the next question. If the area of the cross section is reduced to half, area is half, then what will happen to the flux density? What will happen to the flux density? Okay, so here to get our required EMF, we have to get the maximum flux. Okay, this maximum flux will be depend upon product of area into flux density. We know flux density is equal to flux by unit area. Flux is equal to AB. Okay, so if you want to maintain constant or maximum flux, whenever area is going to be reduced, then in the same way we have to increase the flux density. Then only 2 will becomes cancelled. Then you are getting constant flux. So if you reduce the area, then you have to increase the flux density. How you can increase the flux density? Whenever if you increase the flux, then flux density will be increases. Okay, or you have to use higher flux density material. Okay, so area is reduces, flux density will be double option A. Coming to the next one, guys, the use of higher flux density. Just now we have discussed AB has to be constant. If you use higher flux density, then less area also enough. The area is less also enough. Area is less means less specific weight is also enough. Okay, so that means here it reduces the weight per kVA. The applied voltage of a certain transformer is increases by 75%. So the applied voltage is increases by 75%. That means it will becomes 1.75 times. And frequency reduces by 25%. So whenever the frequency is reduces by 25% means it will becomes frequency is reduced by 25%. It will become 0.75. Correct? 0.75. So then what will be the maximum core flux density? Just now we have discussed that EMF is proportional to flux. Okay, and EMF is proportional to flux is nothing but A, B. Okay, is A, B. That means here flux density and EMF is also proportional to pi F and N. So neglect N, make it as constant. Okay, so then from this one, if the EMF as constant, or if you want area as constant, take it as area as constant. Then EMF is proportional to BF. That means B proportional to E by F. That means V by F. Okay. So flux density will be always depends upon V by F. Whenever the V by F ratio is constant, flux density also constant. Okay. So we have to remember one important point. Flux density is proportional to voltage by frequency ratio. Okay. So the maximum core flux density will become dash. V proportional to V by F. Voltage here increases by 1.75. Frequency reduces by 0.75. That means 25. That is make it as 2 points cancelled out. 175 by 75. 25 sevens, 25 threes, 7 by 3. 7 by 3 means 2.33 times. So 2.3 times. Okay, so it is increases by 2.3 times. Very easy question. Don't feel it is a difficult, guys. Flux density depends upon V by F ratio. Why it is depends upon V by F ratio? We know EMF is equal to pi of N. So let us make it as a constant. Pi is AB, so make it as A as constant. Once the machine has designed, transformer designed, area is constant only. Okay, so EMF is proportional to BF, so B is proportional to V by F. Okay, so as voltage increases, frequency decreases means flux density will be increases a lot. Okay, coming to the next question. In a transformer, if voltage is 240 volt, 60 hertz, having B max is 1.2 Tesla, if we reduce the voltage to 160 volts by keeping B max as constant, then what will happen to the frequency? They have given B max as constant. First of all, you have to pause the video and try yourself. After that one only check with my answer. Okay, so just don't watch blindly. Okay, B max is constant means V by F is constant. So what they have given? Voltage decreases means if you want to maintain constant, frequency also has to be decreased. Here 240 to 160. It is not reduces to half, more than half. So 60 half means 30, so more than 30. So just little bit more than 30, 40. So answer is 40 Hz. If you don't want this understanding, V by F constant means V2 by F2 is equal to V1 by. So if you want F2, V2, what is the V2? Changes to 160 into F1 by V1. F1 is nothing but by V1 is 240. Okay, 64, 66, 61, 6 tens, 40 hertz. Okay, or simply as voltage decreases, frequency also has to be decreased to maintain the constant of ratio. Okay, so 40 hertz. The core flux in a transformer depends mainly on that. Yes, now B max is proportional to V by F. So B is nothing but flux by unit area. So flux depends upon voltage, frequency, supply voltage and frequency. So the answer is option D. Okay, answer is option D. The flux density affects dash. The flux density affects dash. Very important question, guys. Very important question. So flux density affects only eddy current losses, only hysteresis, both hysteresis and eddy current, none of this. It has in both hysteresis and eddy current, whenever coming to the hysteresis losses is equal to zeta B max power X. Okay, X is equal to 1.6 for silicon steel. It may be varies from 1.5 to 2.5 general. Okay, so B max into F into value. So hysteresis losses depends upon flux density, frequency and also value. In the same way, eddy current losses. Eddy. So it is a very simple trick is there. This is our own trick. Okay, that is our patented trick. D into D square. Okay, that means in the formula also all the terms are square man. Okay, except constant. K B max square F square thickness of lamination square. B max square F square and T square. Okay, so it also depends upon B max and also depends upon frequency. Okay, so both losses always depends upon B max into F, B max F. Okay, so both hysteresis and eddy current losses. All of you getting? So in this by using this small trick, you can simply remember the differences between this hysteresis and eddy current losses. It will be proportional to frequency. It will be proportional to frequency square. Okay. Coming to the next question. The frequency affects dash. Only eddy current, only hysteresis, both hysteresis and eddy, none of the above. So by using the formula of these two, Both losses depends upon the frequency. So frequency affects both losses. Both the losses. Okay. So until unless they have given any condition. As per the conditions, it may be changes. Okay. So in general, it depends upon both the losses. Okay. Okay, students, in the next session, we will discuss the remaining question. If you have not subscribed this channel, please click on subscribe button and also please share the information to all your friends. Okay, with your encouragement only, with your likes only, with your comments only, I can do more videos. Okay, and I'm sure you can get a better content. Okay, thank you so much, guys.